Here we go. Our essential question is this. We're trying to identify the process for solving equations with variables on both sides. So we're going to pay particular close attention to the process that we're doing, okay? So we're going to start off. Here we go. With the first idea. And we're going to solve together. We're going to solve this one here. We'll write this down. 15 plus 4a is equal to 9a minus 5. Then, right next to it over here, I want you to draw a line, and we're going to have the process. Before we begin here, right now we have to identify where the variable is, okay? Where is the variable? Right now, talk to your partner, ask them to identify. So we have some variables here. We have 4a on the left-hand side. We have 9a on the right-hand side. Okay? My question to you, which side has more? This side or this side of the variables? Which side? They're not equal. How many a's do you have on the left side? On the left side. The left side. How many? You have 4 there. How many do you have over here? You have 9. Which side has more? Yeah, which side is that? The right-hand side. Okay, good. So if you want to always have a positive variable, move your stuff to the positive side that has more. If it doesn't matter to you, then it doesn't matter, right? You can move it to either side. You get to make a choice. So the first thing that we're going to do, the process here is, for this problem, is we're going to choose a side to move the variable. That's our first step. We're going to pick a side. We're going to choose a side. All right? So I ask you, which side do you want to move the a's to? We can move the 4 on the left over to the right, or the 9 on the right over to the left. Yeah, what do you want to do? 4. Okay, good. You want to move the 4 over? So we're going to subtract 4a here. We're going to subtract 4a there. And here's what that does for us. Here's what it does. It gives us 15. What's 4a minus 4a? 0. That's so nice, right? What's 9a minus 4a? 5a, and then, of course, I have a minus 5. So notice now, all of my variables are on one side of the equation. You guys with me on that part? Yes, good. Okay, great. What's the next step that you want to do? You want to add 5. Good. What are we doing, though? We're adding 5. There's a reason we're adding 5, and I'm wondering what that reason is. Yes, exactly. So, step number 2, get variable by itself. By itself. That's exactly what we're supposed to do. So we're going to add 5 to both sides. You're right on the track. Right on track, dude. So 5 and 15, that's 20, right? Is equal to 5a. All right, good. Last thing, what are we going to do? I know what it is. What is it? Yeah, the answer is 4, correct. But what's the last thing? How do we get that? What do we do? Divide by 4. Now, why are you choosing to divide by 4? That's my question. Oh, sorry. I mean 5. Why are you choosing to divide by 5? It's the only way you can get 5 away. And there's a name for that. You know what that's called? Inverse operations. Because if I were to ask you what's the inverse of multiplying, you guys would say what? What's the inverse of multiplying? Division. So you're using inverse operations. So therefore, our answer looks like a is equal to 4 because, well, not 40. 4 because 20 divided by 5 is 4. You guys with me on that? Okay. Last thing we got to do is we have to check. Okay. How do we check, Mr. Zuniga? How do we check? How do we check? Renee. Is there something we can do to check to make sure 4 is the right answer? Yes. What is it? No, go ahead.
So you start from like where you started first.
Uh-huh.
4 in where A should be.
Yeah, so what do you call putting the 4 in where the A should be? You substitute. Yeah, that's the right word. We're going to substitute. All right, we're going to substitute. Let's do it right now. Here. 15 plus 4 times 4, sorry. Is that equal to 9 times 4 minus 5? Let's see here. This is 15 plus, how much is 4 times 4? 16. Is that equal to, what's 9 times 4? 36 minus 5. How much is 15 plus 16? 31. Is that the same thing as 36 minus 5? Yes, it is. That is our identity, right? It's the same on both sides. We substituted in, and we got 33 boxes, so we're 33% done. Here we go. We're going to solve together. We're going to solve this. 4x minus 12 is equal to 6 times x plus 3. And then, of course, we're going to write down what is our process over here. Our process that we do. Okay, who's got a great idea? What should we do first? Yes, sir. Yes, we should distribute. Beautiful, awesome. Someone write that down. First, we're going to distribute. We're going to distribute. I'm with you. I like it. Let's do it. Here we go. 4x minus 12 equals, what is 6 times x, everybody? Yeah, 6x. What is 6 times 3? Positive 18. Yes, I'm with you. Awesome. Okay, now, notice we have variables on which sides? On both sides. So what's our next step? We have to choose. Which side do you guys want to pick? Yeah. Okay, so you want to move everything to the right-hand side? Okay, I'm with you. So we're going to subtract 4x. We're going to subtract 4x. Good. Okay. So that gives me negative 12 is equal to 6x. Take away 4x. How much is that? That's 2x. And then a plus 18. All right. So far, so good. Now we're in good shape because all of the variables are on one side of the equation. So after we distribute, after we choose a side, what's the third thing we should do? Yes, and what's that called again? Look back up here. What's that called again? No, get the variable by itself. You're almost there. Get the variable by itself. Yeah? So we're going to subtract 18. Subtract 18. And we get this. What's negative 12 minus 18? Negative 30. Is that right? Negative 30? Equals 2x. Great. What's the last thing we need to do? Divide by 2. So what's that called using what? There you go, yeah. Use inverse operations. So it looks to me like, Ramsey, what'd you get, dude? Negative 15. Okay, how do we make sure we're right? We're going to plug 15 back into x. You got it. So let's see here. 4 times negative 15 minus 12. Is that the same thing as 6 times negative 15 plus 3? Hopefully the answer is yes. So let's check it out. What is 4 times negative 15? Negative 60. Beautiful work. Minus 12 equals, what's negative 15 plus 3? Nah, yeah, perfect. So this looks like negative 72. Is that the same thing over here? It sure. Okay, here we go. We have 4x plus 5 is equal to 4 times x plus 5. All right, let's go over the process again here. What should we do first? Who's got a good idea? Distribute. Yeah, you got to do that part first. Exactly. So 1, the process is distribute. There's that property again. So that gives us 4x plus 5 equals 4x plus, what's 4 times 5? 20? Okay, sweet. All right, step number 2. What should we do? No, where are the variables, guys? We have to choose a side. Okay, good. Right now, ask your partner which side they would. All right, Thomas, what do you think, buddy? What side you want to choose to put the variable on? The left side. Okay, so that means I'm going to subtract. I'm going to subtract 4x from this side. I'm going to subtract 4x from that side. Here's what I get. 5 equals 20. Sweet. Okay, when was the last time 5 was equal to 20? Never. Wouldn't that be sweet if it was, though? If you had a $5 bill, you really had a $20 bill? Wouldn't that be rad? It would be, right? It just doesn't work that way. So, unfortunately, is this a true or a false statement? This is false, as we know, because 5 definitely does not equal 20. If you get a false statement, that means there is no solution. Right? There is no solution. We do not have an identity there, right? We get no solution for that one. So, is it okay for a problem to not have a solution? It sure is, right? It totally is. I've been trying to figure out how to lift my truck with my pinky. I just can't do it. There's no solution to that one, right? I can't figure it out. I'm still working on it, but I have not yet found a solution. Right? It just happens, right? It's a joke. It's a bad joke, but it's a joke. Okay? I'm trying to like make the connection that some things in life you just